Welcome to the MecSoft User Spotlight Series, where you can find real customers achieving their success with MecSoft products. Today we'll be spotlighting Polyfab Corporation and their use of RhinoCAM CNC software. Polyfab is a Wilmington, Massachusetts-based company that sells custom fabrication to clients worldwide. Anything that starts with a clear plastic sheet or tube, Polyfab can machine it or form it. The company, originally founded in 1968, was purchased in 2003 by Preston Fisk, a mechanical engineer from Santa Barbara, California. Preston received a master's degree from Stanford, served in the Army, graduated from UC Davis with a degree in agricultural engineering, and worked for John Deere at their Moline, Illinois facility. After 5 years with John Deere, Preston went to business school prior to purchasing Polyfab. We recently sat down with Preston to discuss his use of RhinoCAM software from MecSoft Corporation. The RhinoCAM difference. When Preston purchased the company in 2003, they were laying out sheets of plastic on the floor, using tape measures and string. Seriously. Preston quickly realized that he had to take it up a few levels. When looking for a CAD program, he consulted with a few of his equipment manufacturers. The consensus was that those that started with Rhino seemed to have the least amount of trouble. When Preston purchased his first CNC router, he also purchased Visual Mill from MecSoft Corporation. 3 years later, he purchased a custom 4-axis machine, and it was time to step it up to Rhinoceros CAD and RhinoCAM. 3 years ago, Preston purchased his third CNC router, a Laguna Smart Shop 3. There was almost no transition time to the Laguna because everyone there was already familiar with RhinoCAM. Here is what Preston had to say about RhinoCAM. What was your experience when you first started learning RhinoCAM? What did you think of it?
I liked it. I liked it immediately because I could change the drawing.
Right.
Change the drawing and the code would change.
Right. Mm-hmm.
I mean, fixing the drawing did not mean you had to start the whole process all over, because when you moved the line and fix that problem, the G code all you had to do was post the G code and you were good to go.
Thanks, Preston. What is clear industrial plastic? When you pick any plastic for a project, you choose between chemical resistance, temperature range, strength, transparency, formability, and cost. For transparent products, the typical choices are acrylic, clear PVC, or polycarbonate. Acrylic has the hardest surface, is completely clear, and is well suited to drape forming. It is also the least expensive of the three. Clear PVC is the most resistant to acids and is easily formed, but the sheets are 1/2 inch or thinner. Polycarbonate is by far the strongest because it stretches under load, but is very difficult to form and is very expensive for sheets 1/2 inch and thicker. It is also the softest and scratches easily. The Slurry Tank Project. This project illustrates the use of a thermoform mold to form a 1-inch thick acrylic blank for the base of the slurry tank shown here. The tank, manufactured for a local university, is used to study coal slurry and is still in use today. The images here show the assembly design in Rhino on the left and the actual completed tank on the right. The thermoform mold is required to form the inverted domed base, indicated at the white arrow, the thermoform mold. To form the 1-inch thick acrylic blank, Preston had to first design and machine a thermoform mold shown here. The mold is 40 inches in diameter at its base, with a 29-inch spherical radius that extends upward approximately 5.5 inches. The cross-section drawing shows the thermoform mold. The 0.95-inch acrylic blank heated through to 350 degrees, and the top clamping ring, compressed to a total depth of 3.38 inches. There is also a 1/4 inch diameter center hole at the apex of the dome that is used for positioning while the blank is placed on the mold. A clamping mechanism, not shown, is used to gradually compress the top clamping ring down to form the heated acrylic blank and contain it while it cools. The stock definition. To conserve material and minimize machining time, the 42 inch by 44 inch by 7 1/8 inch stock was made up of pre-cut and glued maple sections, as shown in the image here. The stock was then cut with a bandsaw to remove the excess corners. This irregular 3D stock definition was then modeled in Rhino and is shown on the left. The solid stock model is selected in Rhino and is then defined as a stock from selection in RhinoCAM. Once the stock is defined in RhinoCAM, its 3D model representation is no longer needed and can be hidden in Rhino. The 3D RhinoCAM stock and the 3D Thermoform mold model is shown on the right. 3-axis roughing. To rough out the stock, Preston uses a 3-axis horizontal roughing toolpath strategy that removes material in consecutive Z levels using a 1.5 inch diameter flat end mill. No containment geometry is selected for this cut. RhinoCAM calculates the toolpath based on the stock definition and the part geometry. General cut parameters include a global tolerance of 0.02 and a stock allowance of 0.2, an offset cut pattern, and a step over of 40% of the tool diameter. For cut level control, the step down between levels is set to 0.25, with a bottom limit set to 2.25 inches. The resulting toolpath is shown on the left, and the resulting cut material simulation is shown on the right. 3-axis re-roughing. To remove more stock near the outer diameter of the mold, Preston uses a 3-axis re-roughing strategy that takes into account the previous 3-axis roughing toolpath and only removes material based on the in-process stock. This cut uses 2 circular curves as containment in a 0.5 inch diameter flat end mill with a 0.025 stock allowance. No Z-level limit is set, meaning that all material that the tool can access is removed between the 2 containment curves. The 2-axis outer perimeter cut. In this next operation, Preston cuts the outer perimeter using a 2-axis profiling toolpath and the same 0.5 diameter end mill. This is the finished perimeter cut and allows him to remove the excess outer stock before continuing. The 2-axis profiling cut is divided into a 0.917 rough depth and a 0.07 finish depth. The rough depth is then divided into 0.25 cut levels, while the finish depth remains at a single cut. The entry motion is set to ramp a long path. This entry motion is repeated at each cut level. No exit motion is used. The toolpath and cut material simulation are shown here. 3-axis pre-finishing. As a pre-finishing operation, the 3-axis spiral machining strategy is used with a top outer perimeter curve selected as containment using a 1.25 diameter ball mill. In this toolpath, the tool spirals about a center point, following the part surface until it meets the perimeter curve. The tolerance is set to 0.002 and with a stock allowance of 0.1. The path uses a conventional upcut pattern, starts at the top center, and steps over a distance of 0.188 between each spiral motion. 3-axis finishing. For the final finishing operation, another 3-axis spiral machining strategy is used. This time, the containment is a circular curve that is offset outward from the bottom outer perimeter. This is shown clearly in the inset image on the left. The offset amount is calculated to contain the ball mill to stop when tangent to the top outer perimeter, using the same 1 1/4 inch diameter ball mill. Now, here is the RhinoCAM cut material simulation of all 2 and 3 axis toolpath operations in this setup. And here is the completed Thermoform mold, still on the 3-axis router at Polyfab. Here is more of what Preston had to say about RhinoCAM. Polyfab is a Williamston, Massachusetts-based company that sells custom fabrication to clients worldwide. Their motto, "You design it, we'll build it," is true to its word, with projects that span a wide application spectrum, including architectural, laboratory, water treatment, marine, air handling, and government contracting, all manufactured with the help of RhinoCAM. We want to extend a special thanks to Preston Fisk and Polyfab Corporation for allowing us to showcase the RhinoCAM success. RhinoCAM Mill is available in 5 different configurations: Express, Standard, Expert, Professional, and Premium. The part shown here was programmed using the Professional configuration. Here are some additional details about each of the available configurations. For the complete features list, we invite you to visit the RhinoCAM product page at MecSoft.com/RhinoCAM. This video was brought to you by MecSoft Corporation, your CAM partner.